Today's class we will be discussing about basic terms in thin lenses. The basic term in thin lenses are center of curvatures. It has got two surfaces. It will have two center of curvatures and it will have two radius of curvature. And what is the optic center? What is the radius? These are the things we are going to see. First one we will see center of curvature for convex lens. For convex lens. Whatever lens we are taking, we are talking only about the thin lens here. So this is convex lens. Suppose convex lens is made up of intersection of two spheres. See, this is one sphere. This is one sphere. This is another sphere. So this intersection surface is taken as this is the convex lens, and this sphere, say this sphere will have center of curvature here. This sphere will have center of curvature here. That is, we can take it like this. This is convex lens. This is surface 1. This is surface 2. For this surface, which will have center of curvature here. See. This is for the first surface. The first surface will have the center of curvature here. It means first surface will have the center of curvature this side, and the second surface, this one will have center of curvature here. So this both are spherical surface. This spherical surface, and this spherical surface. This spherical surface is part of this sphere, hence its center of curvature is lying here. This spherical surface is part of this sphere, whose center is here, and its center of curvature is here. So for surface 2, this is the center of curvature. Then a line joining the center of curvature is called principal axis. That is, principal axis means a line joining the two center of curvatures is known as principal axis. This is principal axis, this is center of curvature, and this will have a radius, the distance between the center and this surface, spherical surface, is called a radius of curvature. We call it, since it is for the surface 2, we call radius of curvature 2. And this is from here, this is C1, this is R1. The distance between, so we can write this is R1, R2, and with this one, this is R2. This is center of curvature, and this is the radius of curvature. The radius of curvature is the distance between the spherical surface and the center of curvature. Distance between the surface and the center of curvature. It's called radius of curvature. Third thing, for concave lens. Concave lens, it is non-intersecting spheres. So it is, since it is non-intersecting sphere, we join this part and this part, this portion. So this is the first surface, this is the second surface, and the first surface, spherical surface, part of this sphere, and the second surface is a part of this sphere. So for the first surface, we have, this is center of curvature 1 and radius of curvature 1. For this surface, this is center of curvature 2 and radius of curvature 2. So we can write it here. This is the convex surface, convex lens. This is surface 1. This is this portion, this curved surface. This is curved surface 2. It will have center of curvature here. This is C1, and for this center of curvature is here, and radius of curvature also same. R2, we can write this way also. This is R1. So this is the optic center. What is optic center? Optic center is a point. Optic center is a point on principal axis when a ray passes through it. When a ray passes through it will go undeviated. This will go undeviated for this one. So we can talk about the optic center. This is for a convex lens, we can see this is the optic center. This is optic center. This is principal axis for the first surface. This is center of curvature. For the second surface, this is center of curvature. And the optic center is, we can denote it by O, through which a ray goes, it will go undeviated. This is incident ray on the first surface. This is the refracted ray. This is also refracted ray from the second surface. But actually, undergoes these rays when incident on the first surface, it undergoes refraction in this surface and this surface. So it will go parallel to the incident. The emergent ray will go parallel to the incident ray, which it will suffer a lateral shift. See, when we see it here, this is the lens, optical center, and a ray is incident like this. And a ray is incident ray. This surface, for this surface, the center of curvature will be here. See, C2. For this first surface, center of curvature will be here. We draw the normal with respect to the center. Normal is always drawn at the point of incident with its respective center of curvature. This line forms the normal. So when you see, this is rarer medium, this is rarer medium, this is denser medium, and this is rarer medium. So light is passing from refracted from rarer medium to denser medium. It means it will not go through in its own path, but it will be deviated towards the normal. So instead of going like this, it will be deviated like this. It will be deviated. It is not exactly passing through here. It will deviate. It will go in the straight line within this glass medium. When it is from here also it will go under refraction. For this surface, this is C2, and we draw normal with the point of incidence for the surface with the center of curvature. Then in the ray, instead of going like this, it will move away, because from denser to rarer it is going. So instead of going like this, it will bend away, and it will be parallel. It will be parallel to the incident ray. The emergent ray will be parallel to the incident ray, but this emergent ray will come like this. There will be a lateral shift. There will be a lateral shift between the incident ray and emergent ray. This is due to the thickness of the lens. When the thickness of the lens is more, it will have this incident ray, and emergent ray will have a lateral shift. However, in case if the thickness decreases, if thickness decreases, the deviation, that is lateral shift will not be there. It means if the lateral shift is not there, it means what? The lens, instead of undergoing a lateral shift, it will go through this lens. It will go like this. It will go undeviated. So that point is called optical center. Optical center is a point on a principal axis when a ray passes through lens. It will go undeviated. And this is for convex lens. For concave lens, let's see for concave lens. This is a concave lens. So this is the optical center. This is the point on the principal axis when a ray incident ray will go undeviated. When the ray is incident on the lens, after refracting from both the surface, it will go undeviated. This is called the optical center for both the lenses.